What is up, folks? It's Mr. Walker coming to you live from the internet. Today, we are going into another part of trigonometry right now. Last class, we talked about each of our ratios. We got sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. What are these sides? These are the sides of a right triangle, and these are based off of whatever this angle is that they give us next to your trig ratio. Theta is usually marked either by an X or this symbol, and it'll be the only angle that we're looking from. If we're given multiple angles here, we're going to be looking for all the sides, which means you could use the trig ratios or the Pythagorean theorem, but we'll get into that. So let's talk about some applications for trigonometry. Last time we were just trying to set up the ratios and use it to find missing sides. Today we're going to be talking about how to find a missing angle in this. So to help us out with that, we have the inverse trigonometry ratios. So given two side lengths of a right triangle, we can use trig ratios to work backward to find the missing angle measures using inverse trig ratios. So let's say you wanted to find the angles in this triangle. We can use the inverse of each of the trig ratios to find them. Now, before we get into this, I got to give you a little notification of where to find these on your calculator. So here's our calculator. Let's turn this thing on. An inverse trig ratio is, instead of sine with this -1 in what you would probably look at it like an exponent. It's not an exponent, but this is just telling you that this is the inverse of this. Now, to pull this up in the calculator, you have to hit the second button and sine, and that symbol will pop up. Now, what you're putting inside of here, you got to make sure that you close up with some parentheses at the end of it in case you're dealing with any other math that is in your equation that you're using. You could also do the same thing for cosine and tangent so that you can be able to pull those up. So like this is the inverse cosine, this is the inverse tangent. So when you do this, you're going to need to hit the second button and then whatever trig ratio you're dealing with. Otherwise, you're just taking the actual sine, cosine, tangent. Now, other than that, please make sure that when you are doing it in your calculator, you are in degree mode, okay? If you're not in degree mode, radians is going to give you a different type of answer. We are going to end up using radians later on, but not right now. So, back into the ratios. So we have three of them: sine, cosine, and tangent. The first one, sine, we're going to be looking at this in terms of angle A. So before we even jump into that, look at A. Here it is right here. I'm going to just go through and circle out angle. Now, based off of this angle here, we got three sides. The side that doesn't change is our hypotenuse up here from A to B. Now, according to this angle, our sides are from B to C. This is our opposite side because it's not touching our angle. And from A to C, this is our adjacent side because it is touching the angle, but it's not the hypotenuse. So, with these things in mind, let's go through and talk about it. Sine of -1, or the inverse sine, is you putting the opposite over hypotenuse in this function, and that'll help you find out what angle A is. And since all these are ended up with angle A, essentially what we're going to do is we are taking the sides that we had from the original trig function and plugging those inside of the parenthesis for this. Oop, sorry about that. Didn't mean to get that up there yet. So sine of -1 is opposite over hypotenuse equals angle A. Cosine of -1 takes the adjacent and hypotenuse, pops those inside, and then we get angle A again. And then we have opposite over adjacent for tangent, and that helps us find angle A. So these things are to help us find the angle as opposed to finding the sides like we did last time. So let's go through and let's deal with finding these two Underneath, we got two triangles. They're both right. They give us two sides. We have to use them to find out what our x is. All right, first off, take your pencil. Let's circle our angle real quick, okay? Based off of this angle, we want to go through and label our sides. So, we already know the hypotenuse is the side that don't touch the right angle. Now, for A, we have two sides here. We have 12. Since it doesn't touch angle x, this is the opposite side. 7, because it touches angle x, is the adjacent side. Over here on B, 6, since it's touching angle x, is the adjacent. And we already know this side here for 8, that's our hypotenuse. So, with these things in mind, let's go through and figure out which trig function we're going to use. Looking at A, they give us the opposite and adjacent side of this triangle. Because of that, we are going to need to use the tangent function. So, what we're going to have to do, we know tangent of angle x equals our opposite over adjacent. So, 12 over 7. So this is to find our sides. We need to find the angle. So in order to find the angle, we're going to be using the inverse tangent function. Inverse tangent shows up like this. So we have to find x, we take the tangent of -1 of our math here, 12 over 7. So let's run this in the calculator. We got it in degree mode like they were telling us. Let's clear this out. You hit second tangent, and then you put in our two sides, 12 divided by 7, and then close off the parenthesis. Once you hit enter, this right here is our angle. Now, because this angle is a decimal, we want to go through. Let's look and see what they tell us. They want us to find this to the nearest degree. So, to the nearest degree, this will be us taking 7 and rounding up our ones place. This 7 is going to pump this 59 up to 60. So, our angle that works for this is 60 degrees. Now, when we go through and do this, make sure that your angle makes sense for what we have going on here. Our angle that we have has to actually work if we do the reverse. So if I put the tangent of x in, I should get the same decimal I get from dividing 12 by 7. Let's take a look. So 12 divided by 7 gives you this decimal here. If I put the tangent of angle 60, I should get a decimal that is close to or very similar to this. So let's look. Just about the same thing here. Please note, since we rounded up, that's why this decimal down here for the tangent of 60 is a little higher. But if you did take the first one that we had, let's go through, let's pull that back up. That answer that we got from the inverse tangent, if I plug that in, so the tangent of our answer, that gives me the same exact decimal that I got from 12 divided by 7. So when you do round, please note this is going to be close. It's not going to be the exact same decimal, but at least the first two decimal places will be, just about the same. Okay? So don't freak out if you are checking that and you see that it's not the exact same one. All right, let's look at B. B gives us the adjacent and the hypotenuse side. So that means that we're working with cosine. Our cosine of this angle x is our adjacent side, which is 6, over the hypotenuse, which is 8. And you don't need to have to worry about rounding this. You could, not rounding, simplifying this fraction. You can keep this as is if you're worried about that. So let's plug it in. We got x is equal to the inverse cosine of 6 over 8. So let's whip that up. We got, let's clear all this out. Let's see. where's the cosine? There we go. Inverse cosine of 6 divided by 8 gives us 41.4. And we're going to round this to the nearest degree. So this will just be 41. Now, let's check this angle that we got here real quick before we move on. So let's run the cosine of our answer. This is 0.75. If you take 6 divided by 8, you also get 0.75. So our answer is correct here. Okay, so our angle is 41 degrees. All right, now make sure that when you get this, whatever the question is, we're looking at right angles in a sorry, not right angles, right triangles. Take the triangle, label your stuff so you know what exactly you're dealing with. Because, like how we looked at on our last lesson, opposite and adjacent, those change depending on which angle you're looking at in the triangle. So, label your triangle, see which angle you're working with, and then we move on from there. All right, let's check out our next page. Now, these two angles that we're looking at here, angle of elevation, angle of depression, these are angles that we are going to be using with our inverse trig functions. So, first off, we got angle of elevation. This is an angle created by a horizontal line and the upward line of sight when the observer is looking at something higher than themselves. So, here's our friend over here. He's looking at this hot air balloon. If we're looking at the angle of elevation, we have a horizontal line and there is a line that's going straight from him to our balloon. And that is based off of this angle that we have going on here, this angle of elevation. So based off of this angle, our friend is looking up, up at this. Now, finding the angle of elevation, we'll end up using our trig function because if I draw this line here, we got ourselves a right triangle. So you might end up having to find any of the stuff that's inside of this based off of the information here. Now, along with this, we also have the angle of depression. The angle of depression is created by a horizontal line and the downward line of sight from an observer looking lower than themselves. So, essentially what we're going to be doing, it's kind of like the word problems we did for the Pythagorean theorem at first. We're going to be taking a situation, drawing us up a right triangle, and then using that situation in that picture to find our angles in that new triangle we just made. So like if I go through and look at the stuff that I have here, I have an angle that's going down from the horizontal line from the balloon towards our friend here. And if I continue from our friend here, I end up with another right triangle over here that I can go through and make. So we're going to be using our inverse trig functions for the sake of some of the word problems that we have going on here. So let's take a look at one of these in action. All right, for our example, it says Julio, whose eye level is about 6 feet above the ground, stands 30 feet from a tree. The angle of elevation of a bird at the top of the tree is 32 degrees. How high above the ground is the bird? Round to the nearest 10 of a foot. So, from this, we have our friend here, Julio. He's looking up at a tree at this bird. So, here's our bird. What up, bird? Boom. Now, from this, they said that the angle of elevation from our friend Julio's line of sight to the bird is 32 degrees. That angle of elevation is based off of this horizontal line from him to the tree, and that's how far up he's looking up, 32 degrees. Now, his eye level is 6 feet above the ground, and he is standing 30 feet away from a tree. So what we have here is that he is pretty tall. He's 6 feet. We also know that he's standing 30 feet away from the tree. That's this length down here for this horizontal line. He wants us to find two things. How high is the bird above the ground? And we're going to be using all of this information because right here, this triangle, we, sorry, this triangle that we have is not entirely the whole length of it. So this is going to be a little bit of a barn braiser right here. All right, let's start up the first part here. What are the sides that we got going on for this triangle? Based off of our angle that we got with our friend, we have our right angle, which is right at the tree, which means that this side's the hypotenuse. Over here, where the tree's at, this is our opposite side. Sorry if you can't really see that. Down here, 30, that's our adjacent side. So we are going to be using quite a bit of work. Let's look at the first thing. We want to figure out our trig function. We are going to be using the tangent because we have a length that we are looking for. How high above the ground is the bird? That's the length of this whole tree here. So that means that our opposite sides are x. We got x over 30 equals the tangent of 32. Let's set up the rest of our math. I don't know what x is, so I got to go through and solve for what we have. So these are two fractions equal to each other. We're going to cross multiply here. I got x times 1. I got tangent of 32 times our 30. So x equals 30 times the tangent of 32. Let's pull this up. Clearing that out. So we got 30 times the tangent of 32. That gives us 18.746 and so on. Now, this is talking about the height of this bird. So let's check to see if our answer is right. 18.7 would be it. Okay. Now, 18.7 is how high this bird is from our current line of sight. So the next step we got to do is just take this height from here on the tree to the top where the bird's at and add it to our friend's height over here, 6 feet. So we got 18.7 plus 6, which gives us our full length, which is 24.7. Okay, folks. Now, we got a little bit of practice that we're going to be going through and doing. So let's take a look at what we have. Let me see how many we got for our. Yep. All right. We got for our practice A and B. You guys are going to be doing this last one on your own. All right. So let's get it going. First thing that we got, they want us to find the angle measures indicated, and they want us to round to the nearest tenth. So here's our triangle. We got for A, 35 and 40, not 35, 3.5. Sorry about that. And 4.7. Got some smudge on my glasses. There we go. Now, if we want to go through and deal with this, there's a couple ways that we can use this. We could find what the hypotenuse is and then use all the trig functions available, or we can start off with our first trig function with the size that we got. So what we have here are 4.7 and 3.5 as our legs. This means that if we use these angles, either K or M, we can go through and use our tangent function. So what I'm going to do is I'm going to use angle K as my reference here. Based off of K, 4.7 is my opposite side. 3.5 is my adjacent side. So For this, I want to do the tangent of angle K is our opposite side, which is 4.7, over my adjacent side, 3.5. Now, this right here, this is my uh, regular tangent. We want to find the angle, so we're going to have to use the inverse tangent. So, tangent of -1 of 4.7 over 3.5. Oop, there we go. Let's pull up the calculator. Let's get some calculation in here. All right. Inverse tangent of 4.7 divided by 3.5. This is the angle for angle K. So we're going to go through, we're rounding this to the nearest tenth. This is going to make it 53.3. So angle K is 53.3. Now that we got this, we can really just go through and figure out angle M. We can still do another trig function, or you can go through and do some subtraction. So if you remember from a while back, all three of these angles in our triangle got to add up to 180 degrees. So let's kick it old school style. We got 180 minus 90 plus our new angle, 53.3. So let's go through, let's pull it up, let's see what our calculation is. 90 plus 53.3. And then we are taking 180 and subtracting that answer. Oh, didn't need that. And this is our other angle here, 36.7. So let's put that up there. 36.7, that's angle M. Now, last but not least, they want us to find the length of KM. KM's our hypotenuse. So what we're going to do, we're going to go through, we could do the Pythagorean theorem. Let's make it easier on us. All right, Pythagorean theorem, we're looking for the hypotenuse. This right here, this missing part is C. So all we got to do is add our A squared and B squared and then take the square root of it. So A squared and B squared are 4.7 and 3.5. So the square root of 3.5 squared plus 4.7 squared gives me 5.8600 and so on. We want to round to the nearest tenth for our answer. So this is going to make it 5.9. Let's check it. 5.9 kilonewton. All right. So we got this one right here. Over here on B, we're going to be doing a lot of the same stuff. So let's go through and deal with this. All right, there's a couple different ways that we can find Q or S that you've seen over here. We can do our inverse tangent, or we can go through and actually no, we're gonna need to at least do an inverse, not necessarily a tangent, because they only give us these two sides. All right, I'm gonna be looking for angle Q first. So let's circle Q. Let's label our sides of this. All right. We got 15 here. That's our hypotenuse because it's the side that don't touch the rectangle. Then we got side 10. 10, since it's not touching Q, 10 is the opposite. Let me put that underneath so we don't think it's 100. So I have my opposite and my hypotenuse side. Since I have my opposite and hypotenuse, that means that we're using the sine function. All right, sine of angle Q equals our opposite side, 10, over our hypotenuse, 15. Now, this is the sine. I need to go through and do the inverse sine so I can find my angle. So we have sine of -1 of 10 over 15. Now, once we got that all set up, let's plug it into the calculator. Boom, bam, pop. All right, second sine, we got inverse sine here. We got 10 up top divided by 15 in the bottom. And we got our angle here. Now, they want to the nearest tenth, so 41.8. All right, 41.8. Cool, chilling. Now, I'm going to go through, just like with our last one, I'm going to subtract 41.8 and our right angle from 180 so I can find S. Let's make it easier on ourselves. We don't need to do trig for literally everything. We got a bunch of stuff in our toolbox here. So, we got 180 minus 90 plus 41.8. 48.2, that sounds good for me. It should be good for you. That's our angle. Boom. Not angle. Yeah, angle actually. Yeah. All right, last one. We're looking for the adjacent side. Yep, adjacent side. So we're missing this part right here. This is one of our legs. Since it's one of our legs, we can go through the Pythagorean theorem so we can find that. Or you can use your tangent function. That could work as well. I'm going to use the Pythagorean theorem because I like, stretching out all that, knowledge. All right. Since we're missing the leg, what we're going to do is take the hypotenuse squared, so 15 squared, minus our leg squared, which is 10. And then we'll take the square root of all that. Once we hit all that in the calculator, that gives us 11.180333. Now, they're looking for nearest tenth, so 11.2 should be good for us. There we go. All right. I sorry about that. You got one more example that's going on here. I'm gonna let you figure that on your figure that out on your own. I will tell you that they give you your angle, they give you the length of the ladder. Make sure that you put those angles where it needs to be and the length of the ladder where it should be. And you do have a right triangle that you will see. All right, folks, I'm gonna catch you later, baby. Have a good day.